Hello everyone. Once again, welcome to our online physics classroom. Okay, in the last session, we have gone through electric field intensity, also electric field lines, the properties of electric field lines. I hope you might have studied the properties of electric field lines. It's very, very important. And you must also know the pattern of electric field lines for different distributions, charge distributions. That means for an isolated positive charge, for an isolated negative charge, for an unlike charge, and for a system consisting of like charges. And also we missed one thing. What will be the nature of electric field, or what will be the pattern of electric field lines if the electric field is uniform? Okay, that we will discuss in today's session. Also, today we will start a new topic, that is electric dipole. And why do we need to study about electric dipole? And what do you mean by this electric dipole? All these things we can discuss in today's session. So without wasting any time, let's get started. So what do you mean by uniform electric field? Uniform electric field means the electric field or the strength of electric field will be same everywhere. So for example, consider this area, and we are assuming that electric field in this area is same. So that means if we place a charge here, suppose it is a plus Q charge here, the force experienced by that plus Q charge at this point will be Q into E, right? And if we place the same plus Q charge here at this point, what will be the force experienced? What is the equation to find out force? Yes, Q E, because in the previous class we had discussed electric field intensity is equal to F by Q. So therefore F is equal to, yes, Q into E. So this is the expression for the electrostatic force. So here if we place the plus Q charge at this point, same plus Q charge at this point, what will be the force experienced is Q into what is electric field here? E itself, because electric field is same everywhere in this area, in this portion. And if we bring the same plus Q charge here at this point, what will be the force experienced by that charge? Same, Q into E. This E is same everywhere. Similarly, the charge is also same. So the force experienced by the charge at any point in this portion will be same. So such type of electric field is known as uniform electric field. So what will be the pattern of electric field lines in a uniform electric field? What will be the pattern? It is represented by parallel, equal spaced or equidistant lines. So a uniform electric field is represented by parallel straight lines like this, and the distance between each lines must be same. These lines must be equally spaced. Also, this is also a uniform electric field. Okay, so like this also we can represent a uniform electric field. Like this also we can represent a uniform electric field. But we must know the direction of electric field. Electric field points from positive charge to negative charge. So if this is our electric field, then where will be the positive charge? Yes, positive charge must be here. A negative charge must be here. Then only the direction of electric field can be like this, from positive to negative charge. So if this is our electric field, then where will be the positive charge? Positive charge must be here. Negative charge must be here. So the electric field line points from positive to negative charge like this. And in this case, where should be our positive charge? Here. Yes, our positive charge must be here and our negative charge must be here. So the field line points from positive to negative charge. Okay. Children, let's start with today's topic, that is electric dipole. What do you mean by electric dipole? See, if there are two unlike charges like this, what happens? Yes, there will be a force of attraction between the two charges and they stick together with a finite distance between them. See, positive charge and negative charge stick together with a finite distance between them. Right? This finite distance means what? The distance is fixed. It neither increase nor decrease. Now, if the magnitude of this positive and negative charges both are same, suppose this is plus q charge and this is minus q charge. So what does it mean? Their magnitudes are same, but direction is different, or their polarity is different, but magnitude is the same, q. So such a system in which two equal and opposite charges are separated by a fixed distance between them is known as an electric dipole. I repeat, a system of two equal and opposite charges. So if you consider the system, these two charges are equal in their magnitude. This is plus q, this is also plus q. So their magnitude parts are same, but at the same time their polarity is different. Okay, so that's why we call it as an opposite charge. So two equal and opposite charges separated by a fixed distance between them is known as electric dipole. So you can note down this definition. Okay, two equal and opposite charges separated by a fixed distance between them is known as electric dipole. What is the use of this electric dipole? Why do we need to study about this electric dipole? Children, we can see electric dipoles in most of the chemical compounds. Okay, dipole is present in almost all chemical compounds. Hence, it is very important to study about the electric dipoles. Can you give any example for that? HCl. HCl is an electric dipole. It consists of H plus and Cl minus ion. So here, positive charge and a negative charge is separated by a fixed distance. So HCl is an electric dipole. And you know the importance of HCl, hydrochloric acid. NaCl, common salt. Again, it's an electric dipole, Na plus Cl minus. So it's a chemical compound and it's an electric dipole. It consists of a positive and negative charge separated by a fixed distance. So electric dipole is very important, and it's very important to study about electric dipoles, its strength, and also what happens when an electric dipole is placed in electric field, what happens when it is placed in uniform electric field and non-uniform electric field. So all those things are very important, and we will discuss about all these matters in our further sessions. Dipole moment. This is another major concept of the session. What do you mean by dipole moment? The strength or effectiveness of an electric dipole is expressed in terms of a physical quantity called dipole moment. So from the dipole moment value, we are able to judge the effectiveness or strength of an electric dipole. So what do you mean by this dipole moment? Let's discuss about this concept through an example. Children, here I have considered a uniform electric field, and this uniform electric field is pointing from positive to negative charge. Three dipoles are placed in this uniform electric field. So this is one dipole. It consists of minus q and plus q charge separated by a distance 2d. Generally, the distance between two charges, or the distance of a dipole, is considered as 2d, not just d. It is considered as 2d for our simplicity or for our convenience. And here the second dipole consists of minus q and plus q charges, but here now the distance has been halved. That means if initially the distance was 2d, now the distance is d. Now for this dipole, the charges are minus 2q and plus 2q. That means the magnitude of charges varies, but the distance remains the same, that is 2d as that of the initial dipole. So these are the three dipoles placed in this uniform electric field. So let's find out the force acting on the individual charges. So what happens when a dipole is placed in a uniform electric field? So consider the case of first dipole. Here in the first dipole, this is minus q charge, and this minus q charge experiences an attractive force. That means this minus q charge gets attracted to positive charge with a force. Similarly, this plus q charge is attracted to negative charge with a force. Okay, so what will be the force here? It will be QE. That is the electrostatic force. Here also it will be QE. This will be minus QE and this will be plus QE. So here we can see two forces. One is plus QE, that means acting in the downward direction. Another is minus QE, acting in the upward direction. So we have two forces, opposite forces here. At the same time, what is their magnitude? Here the magnitude of this force is QE. Magnitude of this force is also QE. So we have two equal and opposite forces, right? The forces are having same magnitude, QE, QE. At the same time, the forces are acting in the opposite direction. So such types of forces are known as equal and opposite forces, and this equal and opposite forces is known as coupled. In class 11th, you have studied about the couple and its effect or the moment of this couple. So we have a couple of forces here, and wherever this couple comes, another important property comes. What is that? Yes, you are right. That is torque.